Welcome back. Now that we've talked about classes, we can talk about inheritance. And I think to explain inheritance, I'm going to use subscription tiers as an example. Here's a little image that I drew of a hypothetical subscription model. You will have seen this sort of thing like all over the internet at this point. It is everywhere. You usually have a free plan, and if you pay more, you get all of the features of the basic plan, and you also get extra features on top of that. And then if you jump up in price again, you get all of the features in the previous plan, the indie plan, and you get even more features. Now, how does this relate to inheritance? I'll show you a different image. These are HaxeFlixel classes. When you use HaxeFlixel, you're most likely going to be using FLX Sprite. But it's important to realize that FLX Sprite is built upon FLX Object and FLX Basic. FLX Object extends FLX Basic to get all of the features of FLX Basic. And then FLX Sprite extends FLX Object, which grabs all the features of FLX Object, and then adds its own stuff. To put that idea into practice, I'm going to create two classes. I'm going to use the enemy class from the previous lesson. If you've deleted this file, then I'll let you pause and rewrite this. But I'm also going to create a new file called dragon.hx. Once again, we'll add package at the top of the file and create a dragon class. But this time, I'm going to type extends enemy. So now, the dragon class has all the features of the enemy class. I'm simply going to save this file right now, and we'll go back into PlayState, and I will create a new dragon. I'm going to say var dragon is equal to new dragon. So now we're creating a new class instance of dragon, but this dragon can die. If I run that, you'll see inheritance in action. And there we go. The dragon is saying, oh no, I'm dead. This is the exact same behavior that we saw in the enemy. The enemy has a public function called die, which traces, oh no, I'm dead. When the dragon extends the enemy, it takes all of the variables and all of the functions from the enemy class and gives it to the dragon. This can be very, very useful if you are defining multiple enemy types. So for example, you have an enemy type that has health and the ability to die, and other things that all enemies in your game would have. And then you make more classes that extend from enemy and have their own features. This way you don't have to give every single one of your enemies health. You wouldn't have to define that in every single enemy type that you make. You just define the health here in enemy and have all of your enemy types extend the enemy. So what if we want to make those modifications to dragon? What happens if we want to change what the die function actually does? We can type out public function die. So I can make another die function, and we'll say trace roars in pain, or something like that. If you try to save this on its own, it will actually error on you. But the error makes it very clear. Field die should be replaced with override since it is inherited from superclass enemy. It's basically saying we need to override this function in order to replace the functionality of the die function from the enemy class. You put override right here. If you save that and run the game, the dragon now roars in pain. You can also see that this code is coming from dragon.hx at line 7, as opposed to enemy.hx from before. That previous error also said something about a superclass. The enemy in this case is the superclass of dragon, and dragon is a subclass of enemy. That's just another way of saying that dragon extends enemy or dragon inherits from enemy. But now what if we want to give the dragon much more health? You can do this by changing the health in the dragon's constructor. So I'm going to create a new constructor here. So now the dragon has a constructor, and I'm setting its health to 100, but as you can see there's a big error here. It's saying missing super constructor call. Whenever you construct a subclass of something, you also need to call super with brackets. What super is doing here is it's calling the constructor of the enemy and then setting health to 100. If we go back to here, there's nothing in the constructor, but if I decide to put a trace call in here, enemy created, and then I'm also going to trace the health value on the dragon. If you run this, it prints out enemy created, followed by 100, followed by roars in pain. The reason this is happening is because you construct the dragon, which calls its constructor. In the first line of the constructor, it calls the enemy's constructor, which traces enemy created. Then it comes back, sets the health to 100, traces the health. So now the dragon is constructed, and then we call .die on the dragon, which traces roars in pain. You can also use super in other functions. If we also wanted the dragon to have this behavior, as well as the behavior in the dragon class itself, we can use super.die. And this is just going to call the die method as it is defined in enemy. Remove some of these extra trace calls and run the game. And now we get oh no, I'm dead from the enemy.haxe file and roars in pain from the dragon.haxe file. So what's happening is when we call dragon.die, the code goes to this function. It calls super.die, which goes over to the enemy and calls this function. Then it comes back and traces roars in pain. That is basically inheritance. Once again, I'd like to go over PlayState, because PlayState, as you can see, uses a lot of inheritance. PlayState extends a class called HaxeFlixel, which is part of HaxeFlixel. And then it overrides a function called create. Create is actually part of the HaxeFlixel class, but PlayState overrides it. And then it calls whatever's inside HaxeFlixel's create method, and then calls our code. And likewise in the update function, you override the update function and call super.update using whatever is inside the HaxeFlixel's update method. And just like in any other function, you can pass in some arguments. Alright, here is your challenge. Alright, so your challenge this lesson is to create a person class with the variables name and age, and you also want to give it a function called act that prints a message to the console with trace. After you've done that, you should create a superhero class that extends person or subclasses person or inherits from person, and override the act function to print a new message. So this will be a completely new message printed to the console from the superhero class. And then in here, in the PlayState, you want to create class instances of both person and superhero, and call act on both. If you've done this correctly, both person and superhero should print different messages when you call act. Once again, the answers are in the comments, and I will see you next video.